data types that we have on this safe network, but I guess like Smartedin has already explained most of the implications of these data types. So I will focus instead of that. I will focus on Solid, and I will do a quick run-through of what it actually is, and then I will talk a little bit about why we decided to cooperate with this project, and why we decided to use some of the technologies they also use. So essentially, Solid is I don't know how's this thing probably called. It's not a acronym, but it's like socially linked data. So basically, it's not only about about social data. It's more like it's not even a platform, but it's like a set of conventions and a set of standards, which purpose is to basically the main purpose of the Solid as a project is to give their users a choice. So now we find ourselves in a situation where when we use like our social networks like Facebook or Twitter, and it is like in our minds and in minds of most of people, I guess, it's basically the applications and the things that we post there are the same things. So basically, if we think that if we want to post our photos on Facebook, for example, we think that like this kind of our photos have to be stored by Facebook, and we can't do anything about it. So we just, if for example someone else wants to see your photos, so if you want to send your photos to friends, you just need. They also need to sign up for Facebook, and they also can find your photos only on Facebook, and they also have to use this app just to like basically to interact with you. And it's not really like that it has to be this way, because we don't need to send all of our data to the applications. So it has to be the other way around, that the applications need to request our data from us, and we need to give our explicit consent to use this data. So that's what Solid is about in its basically in its premise, because the Solid is about giving users a choice of where they want to store their data. So this kind of inverses the way that we think about applications and how we build the applications. So usually developers who develop applications, the existing model on the web is that we just create some kind of a server that processes this logic. So if you want to post some kind of a data, so if you, for example, create a blog post or upload your photo on your website, it is kind of expected that this all is going to be handled by a server. And we build our apps with this kind of thing in mind, but it doesn't have to be this way, because it can be structured in the other way. So we decouple applications from the data, so the data is being stored at your own kind of a personal space, which is called pod, so personal data store. And actually, well, Solid is building on a lot of existing standards and a lot of existing protocols defined by like the W3C organization. In particular, it also builds on HTTP, so it is kind of extends the existing internet infrastructure instead of like recreating it from the bottom up, like we at MaidSafe do. So essentially, this idea is that we store our data on our own personal pods, and we have a protocol for applications to request this data from you. And if you give them an explicit permission to get your data, then they can process it and display it in a user interface and like process it in some kind of a way. So essentially, it is also about decentralizing internet, because this data, the data pods, it doesn't have to be stored in just some single location. it can be distributed across the network. So if we are talking about, for example, the existing internet infrastructure, this data can be stored like partially on Dropbox, partially on Google Drive, or partially at your own home server. And the applications would have to combine all of this data to present it to you in some kind of a convenient user interface. So, for example, your comments can be stored like on your own personal server. The likes for your blog post will be stored on some another, but it will be all combined and displayed on a single page. And to make it all of that work, Solid builds on the ideas it largely relies on the ideas of the semantic web. And the semantic web is, well, it's a grandiose idea. It's like a very, very big thing that every single piece of data that we upload to the network has to be connected to some other piece of data. So, for example, if you have your user profile and if you leave a comment on some website like Facebook, this comment will be linked to your profile, and essentially it creates all of those links create this vast network of links which you can traverse. So essentially it's the same, it's almost the same idea as the web itself, but instead of linking just the web pages, we start linking data. So that's the main idea behind the semantic web. So actually it comprises of several standards. It uses several standards, and one of the standards it relies on is RDF. And RDF is actually a lot of people, in the minds of lots of people who have heard about RDF, it's a very old thing that really nobody uses, because in the minds of a lot of people, it is a thing that kind of relies on XML, and no one, it's like, not a lot of people use XML nowadays because it's not very convenient to use. But really, it is not, because RDF at its very core is a very simple idea. It's like, it's just a way to represent the data. It's like a very, very abstract kind of thing. It's not like HTML where you define like how your page is going to be, it's going to look. RDF is just a way of thinking about data. It's a way of modeling your data, and it also, in particular, it also allows you to create links in your data. And how you represent this data is not really a matter of RDF as a standard. So you can represent it in multiple formats. You can store it anywhere. So basically, this idea, this abstractness of RDF allows us to store it anywhere, and in particular, we can store it on the safe network as well, but more on that later. So another thing that like the semantic web comprises of is the query language that is called Sparkle, and it specifically was designed with this idea in mind that the data will not be just some kind of a static thing. It will be like a very dynamic linked, where we have like lots of links, and the data is stored not just at a single web server, but can be stored like at multiple locations. So this query language is very similar to SQL. So for a lot of, I guess for a lot of developers, it will be a familiar thing and familiar concept to query some kind of a data from a database. But in this case, this database is not here just some kind of a single database server. It's going to be the entire web. And this query language allows us to combine all of the pieces of data that we store, like your Facebook comments, your Facebook stories, your likes, and all of the tiny bits and pieces of data. It allows us to combine it in a single place, and to process this data and to present it to a user in a straightforward way. Basically, there are some more details to Solid, but essentially it's a set of protocols. It's also like deals with the authorization and the access control lists. So basically, it defines the ways that applications ask you to request you to give permission to the data that you store at your personal data pods. So it's all defined by Solid. And essentially, considering all of that, Solid in many of its concepts is pursuing a similar goal to what we do for the Safe network, because the main purpose of Solid is to give users a choice, and it gives the users an ability to store data in a decentralized fashion, and that's what we also do. But the thing is, like, we still have differences, because Solid still relies on HTTP and many of the existing protocols, and in my opinion, this approach has some advantages, but it also has its own downsides, because if you think about it, like, how do we deal with the situation of storing data at multiple locations? So actually, if we go a little bit back in time, the internet, when it was like invented and when it started functioning, it was a decentralized network from the beginning, because like when we used protocols such as email, it was completely decentralized. There was no idea that your email has to be like just on a single server at Google. It was a completely decentralized protocol that multiple computers used to talk to each other, and the protocols were decentralized as well. But now we have come to this situation that, like, I guess I would say that it's probably safe to say that no one in this room runs their own email server, right? So we have to rely on third-party providers to provide this very essential service on the internet. So we have to give our power and our responsibility for this to third parties, such as Google, which can now store all of our email and all of our data, and it stores like emails of hundreds of millions of people. And now it comes to this situation where we log into our Gmail account and we can see like advertising based on the contents of our email messages, right? So really, what I'm concerned about what I'm concerned about here with Solid is that it might come to essentially the same situation where people don't really want to care about running their own servers, because it's like it's also a matter of resources, it's a matter of user experience, because it's really like if I want to run my own email server, I would have to learn a lot of things, and why do I really need to do that? It's really complicated, and what do I get out of it, right? So it's just easier to use Gmail for that. So the same thing could actually happen with Solid pods, because the idea here is that it's it's just a protocol like email that computers can talk to. It's a way like that many parties communicate, right? So it's not defined that the pods have to be like created in a very specific way. So it's left to a user's choice. So essentially, what it gives us is huge freedom, because pods can be provided by your own home server. It can be provided by Google, it can be provided by Dropbox, it can be provided by any third party, and it can be like that you pay someone for storing your data, and it can be like you pay, I don't know, $5 a month for like 1 gigabyte storage, and it can be just like cloud storage you use today. But the thing is, like, in the beginning of the internet, like in the mid-90s, there was, on the beginning of the web, sorry, in the mid-90s, when email started to come to the web as well, we had these like email services available on the web, and it was really all convenient. And those email providers took money from you for you to use their service. So it was like you paid money for using to use your email. But then free services started to come up, and it was really hard for the paid email services to compete with those like free services like Gmail, which gave you like 1 gigabyte of data for free. So essentially, they used a different model of covering the costs of their service, and it was like, for example, advertisement. So they scanned the contents of your email to show you ads, and it was really hard to compete with the scale of Google. It was really hard to basically to market the paid services for email. And I'm really afraid that the same thing can happen to Solid, because Solid does not really dictate how your data have to be stored. So this data doesn't necessarily have to be encrypted. So what we really come to again is that if you, for example, if you post your data at Dropbox, okay, you pay your 5 quid, you store your data, but then there is a new pod provider like Google, for example, and they provide this service for free, but in exchange they can scan your data, for example, for I don't know, and show advertisements based on the data that you store. So really it gets us back to the same situation of like incentives and basically the incentives for third parties, for the parties that provide storage for you, and it might come to the same story as with email. So really, what the idea here is that the good thing about this is that those pods are not defined very strictly. So the safe network can be essentially a backbone for Solid, and it can use the same protocols that Solid applications use to store this data on the safe network. And these data will be encrypted by default. So meaning you can use the applications that were created for Solid and for use on the ClearNet, but instead of running them on the ClearNet, you can run them on the safe network and pay the safe network to store this data. And it's not like the safe network is just some kind of a party that you just pay. It's just the entire abstract network, right? So this payment is going to be distributed across all of the nodes that comprise the network, not just some party. And your data cannot be snooped. Your data cannot be just retrieved by anyone but you. So it gives all the preferences of the safe network for the pod storage, and also. The benefits are not only for the Solid, but for the safe network as well, because it's basically a twofold thing. So Solid apps can store the data on the safe network, but also the safe applications can utilize the Solid protocols, such as RDF and link data. And actually, it's a huge thing because, as Pandon mentioned, now we are. Once the data is published publicly, when it's available on the network, you can't change it. You can't delete it, and it is very important specifically for linked data because, like it was mentioned, there is this problem of link rot, and it is especially important for linked data because once you have a little bit of a little comments on your social network, right? And if it's stored at some pod, and if this pod goes down, you can't retrieve it anymore, and this data is not accessible. And what if it's not just a comment? What if it's just some kind of an important link in the whole semantic web? So storing the data on the safe network solves this problem, and it is very important because this data is stored in perpetuity, and you can be sure that this data is not going to change because there is this huge problem on the internet, even for the web pages, and it's not like you can't find the important information on the web anymore because it is stored. It was available once, but then the server goes down, and now there's a completely different website at this address now. it was changed. And you can try to find this data on the Internet Archive, but actually, if you think about it, so many
websites were totally destroyed.
Yes, yes.
Some of my favorite websites they're fragmented. You can't find them.
Yeah. So if you think about it, it's like there are so many examples of this. So like there were image hostings like that were completely destroyed, and this information is not available anywhere. So there were like valuable information like that the communities created, that people created, like for example guides or references or books or whatever, and this data is not just there anymore, it's destroyed, and it's like it can't be found anywhere.
And the community can't be traced and backtracked, and like it was history and it's gone.
Yes, exactly.
All to Vista type stuff. You just can't find anything.
Yeah. So the same problem applies to linked data, but like it's even more important for linked data because essentially linked data is based on links, and it is like implied that these links will be always available, and the data that is stored with these links will be always accessible. So we are also solving this problem, and we are currently we're looking for ways to basically implement the RDF, this thing that is called triple storage, on top of the Safe network. So we want to store the linked data on Safe to use the query language to fetch this data from multiple vaults and to basically do the same thing as Solid does, to present it in a coherent fashion, like in the user's interface. So there is also like it's all very interesting, and it's all like it's just you can think that it is all like theoretical, and it's not. It doesn't apply to the real world. Well, okay, like we have this RDF, we have this Sparkle, and it's all like academic stuff, which like not a lot of people are interested in. But really, it doesn't really apply to only to like some academic environments or like even like enterprise environments. It is also very important from the standpoint of basically not having to use the proprietary programming interfaces, because now what it essentially means is that the data becomes completely available, because now if you want to get some kind of a data from, like if you want to create an application that, let's say that just a simple example, you want to create an application that shows your Twitter feed and also your Facebook feed right along each other, right? And if it sees that there are duplicate entries, it will show just one entry, right? Very simple idea, very simple application, but you can't really do it now. Well, you can try to, but you have to use the ad hoc APIs provided by Facebook and Twitter just to get this data in the first place, because the application is pretty simple conceptually, but the complex part of it is just getting the data, because Facebook and Twitter have proprietary APIs for this data, and it doesn't apply only to Facebook and Twitter really, because it can be an open website, it can be like a community-led website such as Wikipedia, but Wikipedia doesn't provide the content in a predictable way. So, well, probably Wikipedia is a bad example, but it's like there are websites which provide a community database. And to get the data from these community databases, you have to use their APIs, and there is no single standard how these APIs work, right? So there's this thing called like REST API that a lot of people, a lot of developers agree to, but it's not like homogenic. It's like each of the like all of the websites basically invent their own thing. And what Sparkle and the Sparkle give us is a standard and predictable way of getting data from the network without having to use the proprietary APIs. And it is very, very important thing, because essentially it gives you the ability to build this app, like getting your data out of Facebook, getting your data out of Twitter, and presenting it in a single way. And it gives us actually it gives developers an ability to compete with Facebook and Twitter, because those are not valid guardians anymore. The data is accessible to everyone who wants it, and it's not like owned by large corporations, it's owned by you. And the applications can invent a lot of ways how to use this data, and you can use it in a single, the standardized, predictable, and user-friendly way. So this is a very important thing. Another advantage of bringing the solid and the safe network together is that we can combine two developer communities, because basically if people start building applications for Solid, which they already started, and they want to bring their applications to work on the safe network as well, they don't really need to learn the new APIs, because with the safe network we provide like some kind of building blocks. We provide the native data types, and it might be a little bit hard to grasp all of those new concepts, especially if you're new to this whole decentralized internet thing, and it might be hard to understand what the immutable data is, what is dependable data, and how it all works. So essentially what we are aiming for is to provide an API that is familiar for developers who worked with Solid before, or maybe even worked with just like in JavaScript or like with usual web applications. And essentially what we want to provide is an abstraction on top of the existing safe network API to build their applications using those those existing web standards and the existing technologies. And it's probably too early to say, but essentially it would be also good to have a complete interoperability of the of applications that were created for Solid. But it might be a little bit hard of a problem because it still relies on the internet infrastructure. So if you want to, if your data is partially stored on the ClearNet, on the existing internet infrastructure, and the part of your data is stored on the safe network, it might be hard to combine all of them together because it poses a security problem.
Could you set up automation to mirror, say you had a website on the ClearNet and you wanted to present that same information on the safe network, could you set up a network to automatically mirror the data from the ClearNet onto the automatically, pretty simply?
Sure, and there are existing projects by our community members for this, they do exactly this. So you create your website, you can publish it on the internet, you can publish on the safe network, and it can be done automatically, it can be automated.
So basically you're saying talk about Solid again.
Yeah.
Some of the information you want is on the ClearNet, and some is on the... But you can have an aggregator on the ClearNet that's searching for information that's being requested on the safe network. Yes,
of course, but it's also it's just a thing off the top of my head that it has some security implications, because really, I guess we generally don't want to go from the safe network to the ClearNet because
that's why I say have an aggregator.
Yeah.
So that you've got a place that is trusted by the safe network that is receiving requests from the safe network. Find me this information. And we'll come and get it sometime later, according to...
Yeah, specifically for Solid apps, for example. Yes, that is possible, but it's it's still not clearly defined yet, but it is theoretically and practically possible. And to answer to expand a little bit on your question of can we automate publishing the websites on the internet and also on the safe network? So just to clarify this, it is of course possible, but you should think about the safe network websites as static websites. So what we have with front-end applications, which are single-page applications, basically. So
it's the consumability of the safe network with an aggregator that you've got to mash up. to your choice.
Yeah.
What that would be. Yeah.
Yeah, I mean, because somewhere you've got to have an interface between the two, you know, and you've got to have somewhere where there's like an entrepot, you know, where you can have information, because it's come through this entrepot, it's trusted to go there, through that border without being checked, for example, because it's got a ticket on it, or there's a customs seal on the back door of the lorry.
Quite nice. As long as you pull the data through and it's not in any way it's going to be able to stick into the network, it's just being transported through it.
It's pushing outwards.
So it can't inject anything.
Yeah.
In theory, you would be worried.
But basically, like, what I wanted to say is that we can't move all the websites that currently exist on the internet to the safe network, because there's also this aspect of the backends, the backend software that runs on the servers, and we don't have servers. We can't really like run the backend project.
So if stuff wants to be done, they would need to make their own structures within the safe network that take from what that structure code for, so it works. Doesn't have loads of proprietary bullshit.
But the good thing is, like, the solid apps also are built in with this idea in mind that really, like, the data processing is happening on the client side. So this is the same thing as with the safe network. So what's called key apps or centralized apps. Okay, so about the current status of this whole thing on the safe network, we already support linked data and RDF data on the safe network, and you can already use it on the running community network or our own Alpha 2 network, and it was developed by our front-end team. So you already can use this kind of data, but what we are looking for is to support this kind of data on the backend side as well, to basically make it a part of the core APIs that we provide. Because currently what we have with RDF is that any developer can do that, because the safe network is not really concerned about what kind of data you store there, right? So you can store like anything, and one of the data types can be RDF, and basically it's not like set in stone that you have to use RDF to store your data.
So ontologies would sit on top of your data.
Yeah, well, what I want to
transpose.
No, what I want to say is that basically what we want to have is not that RDF is kind of provided by third parties. It has to be like a part of the core network APIs that we provide, so that the developers can build their apps using the RDF technologies. And one of those things is that we ourselves want to use RDF for some of the core network applications, like, for example, storing files on the network. Because the problem here is, one of the reasons why we decided to go for Solid and why we choose to go for RDF and this Solid technology stack is because we don't want to invent our own kind of data models. So the data model is a very simple concept. So it's just a way that you represent your data so that other people can use it. Basically, if you know the data model, so you know that, like, if you have a file, you know you have a file name, you have this like metadata, when this file was created, when this file was modified, and if it's predictable, you can rely on this data model to build like a file explorer, for example, or like a file storage. And the problem with that is that we don't really want to deal with that. We don't really want to invent our own ad hoc data models. So we take this idea of RDF schema, which basically allows you to define your RDF data in a predictable way. And actually, the good thing is that those standards are defined by not by just some random people, but by big organizations such as like W3C, which defines the HTTP standards, or not HTTP, HTML standards, and such kind of things. So it really gives us an option to make the network, the safe network, interoperable and understandable for other people, because the data models that we use can be found on the internet, and anyone can use them, and it's not like some kind of a convoluted thing that we ourselves invented. And there are already the projects demonstrating the capability of running solid applications on the safe network that were created by our community members. And I guess like the future work in this area for us is to make this like interoperability also part of the core APIs that we provide, so that you don't have to so it will be easier from the user experience standpoint to use this bridge between solid and the safe network. Then we are also bringing this query language to the network, and it will be also running on the client side, because like Spotted explains vaults. If we start to control vaults, it's really complicated to run queries on the vault side, so it will be all done on the client side. And there is also like this problem of user experience, because it's really hard to learn new things, and it's really hard to learn new things that such as which involve a lot of new concepts, such as Sparkle. Well, it looks like SQL, but really it is a complicated language because it relies on new ideas and new concepts. So we are also looking forward for the progress that's being made by the Solid community and by the Solid developers in this area. And one of the examples is LDFlex, which is a kind of a language that runs on top of Sparkle. And allows you to write your queries for data in a very straightforward way without having to rely on
LDFlex. What's it called? LDFlex.
LDFlex, yes.
Yeah.
So actually, it's developed by Ruben. Who developed this yesterday.
Is Sparkle like SQL but for distributed queries? It's primarily used in
Well, you can think about it as like with SQL, you request data from a database server that speaks this protocol. But Sparkle was specifically designed with HTTP in mind, so it is a protocol to query the web servers for this piece of data.
But it's like a 12th generation.
Yes.
Better. I mean, it's sort of
you say what you want rather than how to do it.
You've got the ontologies that you support,
Yeah.
and you refer to them. Yeah, that's all objects, they're abstractions, which are really sweet. They're great. Well, it's been around for a long time. We used to call it about 15 years ago. So it's very aged.
I think it was invented in 2001, so it's 18 years, yeah, at least.
Well, on this will be less debate on how to pronounce it.
Sparkle.
Can I ask a quick question?
Sure.
There are spiders that crawl the web, indexing pages and stuff. Is it possible to create a spider to crawl the safe network? And say, for example, I wanted to find all of the chunks of my data. Can I set up a team of spiders with, all of my data is addressed with a graph, isn't it?
Yes.
So if I make a bunch of spiders with the graph for each piece of data that they're looking for, they can go crawl the safe network and find all the chunks necessary.
Well, the thing is, if they're talking about the data, yes, of course it's possible, and I would say it's even desirable, because that's one of the beautiful sides of data, is that you don't have to extract this information from HTML pages as Google does. So we don't need to extract the meaning and the semantics out of the data, because the semantics and the meaning is embedded in the data itself, in the data description itself. So that's a very good thing, and it essentially.
We're only talking about public data.
But I'm just thinking
yes,
that if somebody wanted my private data, all they've got to do is
That's
set
it,
off
yeah.
their team of spiders to go look for my data. It doesn't matter how fragmented it is, they're going to find it.
No, that's the
It's exactly the fragmented.
No.
They're just going to.
no.
But if they've got the addresses,
No.
then they can find the information.
Well, if they have the addresses, they'd have your keys, so it wouldn't be.
Yeah.
The thing-
Okay, so nobody can actually engineer a little herd of spiders to seek out my data.
Assuming the encryption isn't compromised.
They can have the addresses, but still not have the keys, so they won't fetch your data. But it's
Yeah, I mean, then it's encrypted. But one of your defences was the fact that it's sharded and distributed. Well, I set my team of spiders to find all the shards, and that's one of the problems
the
overcome.
sharding itself is less to do with security, more to do with uniform distribution of data. So
Right,
that you
yeah.
don't pull all
Yes,
one.
yeah.
Because it's very
And
simple.
breaking chunks up into discrete packets,
Because if
basically.
I'm that interested in you, it's very simple for me to just monitor you, right? And I'll
Well,
just
yeah.
monitor right at the source.
Right.
And at that point, it doesn't even matter if it's shrouded.
Yeah, and you can look for where I go in and out, same as Tor network and all those
Exactly.
things. Yeah.
But yeah, and like if you want to, for
But if
example,
you want to find data I previously put there after you start
It's very
monitoring,
difficult. Yes, but I wouldn't put my I would risk my life saying that
Yeah.
maybe they cannot find it. They might.
It's published and private, so published stuff will be cool.
yeah, and the
Because
private
it's-
not. Yes, it's got no address on the
Go
network.
about and any links to. That's how web crawlers
Yeah.
work. They go between links between stuff to find all the stuff to aggregate.
Yeah.
So if you published it, then yeah, you'd want that to happen because
You want it to be
Yeah.
found.
how would you able to index and make a
Yeah,
useful
MaidSafe.
like public internet?
You'd have made it favourable to be spotted in the first place.
Yeah, unless it says to the spiders, don't crawl.
My main thing I think in everything is social engineering. I mean that beats security or anything like that. Because if I can just lure you into believing
Sure,
it,
yeah.
right? So at the end of the day, I think like it'll come down to all those aspects as well.
You're a young lady with loose morals, for example.
Yes.
but the beauty of this thing is that like the crawlers can know that with the data types that they have, with the immutable data and the variable data, they don't have to like continuously rescan the entire network like the Google spiders we did.
Because the address is permanent.
Yeah, because if we know that this data is immutable, there is no point in going there again. There will be nothing new because it can be like it can be changed, right? So,
having a search engine on top of this would be
well, it's like it's hard to say that currently. I think there are some community discussions about this search thing, but well, actually there's like there's some links. You can find on the community forum, so safetyinform.org, and there, like it exists for at least 5 years, and there were a lot of questions that were discussed there, and including this search, and including like many of the societal implications of this technology and all of this stuff. So, like if you're interested in
using
that,
Sparkle underneath. I mean, that's beautiful. It's an ideal engine for your research.
But I guess it's like it's a question for the future because currently we don't develop any kind of search functionality. But I guess like it's a very natural thing to think about this.
You might, if you want to like setting up a distributed search engine, as opposed to like saying I'm going to Google to scan it. It's like I'm going to pay the gets for like indexing my page, and then they're all publicly built stuff that gets built onto the same thing, so everyone would put data storage into making the index.
Exactly.
Something along those lines.
Yeah, I think that if you incentivize something, then anything is possible, right? So you just incentivize saying that you come to me and tell me what you have done, and I'll pay you kind of stuff.
I was thinking of an existing open source search engine, sort of like sitting on top, gives what I see, what sitting on top of this.
I don't think it's all just.
It's already there,
Sorry?
it's already there, written, it's open source.
For the Safe network, you mean?
No, I mean, there's another product.
Oh, right, okay, right, yes.
Is that the one you showed me yesterday?
Yeah.
What's it called again?
YACY Hacky.
Yeah.
The distributed sort of search engine.
Just another question: is the search engine able to see the diffs, the public diffs, as they're committed, so it can just spider those?
Yes. Because like with the
much more efficient than like Google or Press.
When you say public this,
So you commit a public change to your website, it's visible. The search engine can see it. It just needs to spider the diffs as they're fed in, rather than having to go and actively check websites to see if they're updated. So it's a step change in terms of search engine efficiency.
Oh, so you already have got this like internet archive functionality that's in the network. So if you want to find the previous version of a particular website, you can just like click the slider and slide back in history. So the same thing can be done obviously like by the crawlers. So yes. And yeah, so if you want to learn more like about all of those things, I would suggest you to join the community forum, and it's a really friendly place. And like if you have more questions about like how this thing works, I guess like there is a big chance that it's already been discussed in the community forums. But if it hasn't been, feel free to create a new topic and discuss it there. So there, if you want to learn more about Solid, there is this Solid website, and there's this website for the Safe Network, safenetwork.tech. And I think that's about it. So if you have any questions.
The implementation is a must.
Yes.
Yeah, so I mean, how many developers do you have actively? You've got GitHub, you're committing to the latest builds.
Well, it's like Spartan Slate. We have basically the MaidSafe team is divided into two groups, like the front end and the back end. So the front end is working on the user APIs and like the user-facing applications, and the backend works on all of on the backend. So for the backend we use Rust almost exclusively, and for the front end we use JavaScript. So the backend team is I think about 15 people, or so yeah, about roughly 15.
I mean, you collaborate with Mozilla at all?
No.
They collaborate with this because they're about open-ed.
I don't think we have collaborated with anyone. We did collaborate, or we are collaborating with maybe POA networks. Because there's a guy who's working for POA called Andreas. He used to work previously for MaidSafe.
Okay.
So he's working now for both MaidSafe and POA. And that BLS thingy is one of the things that POA is interested in, and so our
what's
file going.
PLA?
Sorry?
What's PLA?
Is that an acronym of the name?
POA. I guess they are based in the US or they are headquartered in New Zealand. I'm not very sure. But they do something very similar in the first place. So yes, so that's the only collaboration I'm aware of. Apart from that, I don't think it might do, because we're watching some universities from the.
There's a lot of government open data initiatives, but they're very stilted. And the Open Data Foundation is just it's just ground to halt.
Can I ask you, right, essentially, when I first heard about it, sort of joined into this, it's maybe as an investment project. And then when I looked it up, and it's like, oh, it sounds a bit like Dropbox, and then I suddenly like, it's like, oh, shit, it's kind of situation. But then I probably went a bit overboard in my imagination, and I started thinking of making like kind of safe net entities living on it. And then I realised I've forgotten something quite important, that it's only data storage and it's not computation, and you would need people to interact with it. Is there any kind of thought of doing something along the lines of distributed computation, so you could put like, if you were going to make an artificial life type thing, that instead of having a vault, you would have something similar, but you would basically be giving compute time, so stuff would come down and there'd be some kind of virtual machine that would be able to do stuff
That's an interesting idea because
So-
people who are on that safe network might have a project in mind which is absolutely contrary to the ClearNet, and by providing resources, you then have a bunch of power that you couldn't otherwise obtain.
And the browser, the Firefox browser has got the server parts of it, they're called server underneath. That can allow parallel computing. It can consume the fabric.
Yeah, so you could follow
the machine.
basically, yeah.
And if you're writing in Rust, you've got all of that. So that's what I'm surprised you're doing front end in jobs. Well, I suppose it's not for compute.
Yeah.
It's for presentation.
Well, I guess like that. We are also looking into WebAssembly, so I guess that's also like the future of the front end development.
Yeah. So it's a natural progression. So back end becomes a front end to an extent.
My original question, is there any... I thought when I read something like the original, it said something about...
So the thing right now is, I guess, the focus, like, even without computation, if this thing launches and when this thing launches, it's going to be such a huge thing that we think like computation would be kind of a solved problem after that, because all people need to do is like have something that is working on add computation. But if you have computation, that would do a world of good theoretically, at least, because you'll have those parallel queries and stuff running on the walls and stuff.
So it's kind of like, I am going to use the word server, but like put something on a server so it can run without people having to touch it, but it's not actually a server. That's without people touching a decentralized server.
Yeah.
You probably need to think of a new patchy name for it. So
It's just a task, an ongoing task, isn't it? Communal task.
as long as you just
Because what you can also do is you can make a so there's just off the top of my head, right? Maybe it doesn't even make sense. So maybe you can make like a CPU pool out of just clients. So you can have clients, and all walls need to do is do a push notification. So if you want to do something, you tell the walls, hey, can somebody do this for me? And people can register to the walls and they can just push it.
Is it
possible
video rendering?
to really
for example,
Yes.
shit like that, anything, all sorts of stuff.
Yes. So then the clients kind of opt into being a part of the CPU pool, whereas it's not mandatory for all the walls to do it.
Right.
So all you do is, like, for instance, if you want to render something, you just tell the walls, can you find somebody who can do this for me?
Yeah.
And people can register, and then walls can do those push notifications which you don't have right
We
now.
have micropayments for some.
And then you have payments, right? So you have
you
more.
have a sort of blockchain payments distributed system.
Right.
Which your hot wallet could be implemented in Rust.
Right.
It's a, I mean, that's a,
Okay.
you could introduce payments as well,
Yes, exactly.
organically.
Yes, because that's how the farming actually takes place, right? You are kind of monitoring what you're doing, and then you get to give a wallet, and then the entire network kind of pays you into that wallet, right? So when you run a vault, you basically advertise your wallet, and then when you do something, for instance, you respond to a get or do anything, right? The network recognizes your contribution, and then it's going to pay you. Maybe you can contribute to your CPU pool, and the network recognizes that as one more contribution, and then pays you for that.
If somebody developed a game that could be played on the safe network, it doesn't matter how daft it was, but if it went viral, and the only way you could play it was by being on the safe network, that dragged one hell of a lot of people on.
We already have that example, but the only problem with that was, for two people did make games, and it was, as you said, not a very shiny game. You had to put like something and then moved after a long period of time and all that stuff. But the initial draft was there. I guess like people will be a lot more interested once you actually run the network in the public. For two, we are running it in our DigitalOceans, right? So people can still go and say that, okay, everything is MaidSafe code, but it's still harnessing the power of the DigitalOcean and not the people's computer. Once you do that, and if it still runs fine, then people will be very interested. Because then you deal with situations of malice and all that stuff. That's the main problem. If you don't have malice, I think we will be lost right now, because the DigitalOcean code works. The thing is, like, those are not Byzantine net machines. So
The lower latency of 5G will make edge computing swarms.
Yes.
Greater ability to do this.
yes.
The gaming, etc. So it's going to happen.
in terms of
It's we've been in it for a long time, and it's not happening on all levels and on all platforms, and it will continue and expand. It's simple. We have to deal with it. It's not going to go away.
It'll be owned.
And you just have to, constantly adjust. That's all there is.
I mean, it'll be owned if you don't do something about it.
Relatively, do you think it would technically be possible, right? If we're talking about like a multi-player computer game, say one that currently exists, but due to games and servers, the server that you want to run, would it be possible to recode it and run it really quick? And so it would technically not be any way not be able to be shut down.
Yeah.
In theory, it would probably be fine.
Or run it on safe network and not be shut down.
Game of risk.
Yes.
But so it would be through direct connections that most of the things happen, because obviously you can store all the data.
Yes, because what you can do is you can just use the network to kind of find other people, right? And once you find them, you can use net reversal to directly connect to them and then form your own kind of a leak, and then you clear the link. So you don't even have to involve the bots at that point. I think we should see some WebRTC stuff in safe networks. We at least exchange data, and then it's up to the clients to discover themselves via the safe network. You exchange data, your information via the safe network, so it's reliable and it's secure that nobody's looking on it. And then once you've done it, then you can just form your own small group to play with that. Right? But yeah, I guess like the applications will be just a matter of imagination at that point. You just need to think in a bit skewed manner, because people approach it as thinking it's a server-based model, and then they get surprised because they need to download.
Do you think there would be enough latency in it, for say, if you're going a full-on action game, to actually work?
Yeah.
It's the map service, isn't it? And weather service and things like that.
Yeah,
Are the problem.
yes, to rearrange themselves in terms of latency and access for reading data. So, in terms of just reading your data, I would say yes for now. In terms of like machines processing, that's probably not much.
It all depends on like UK and most of EU, I guess, have the world's fastest internet. Netherlands, I guess, is the fastest in the world. They have a speed of 1 Gbps or something like that. But maybe Germany. Maybe in the next 10 years, when the world catches up to that, maybe we don't have latency. But those will be the solved problems, right? You know it is because of the network bandwidth here, I'm joking. So at some point you won't have that, and then
You don't think the latency will be that different to that classic?
I think initially it will be very
There's a massive convergence with IoT as well, because you get a smart city type
Yes.
domains of information converge together.
Yes.
So that's interesting, because that safe network then becomes streamed data. So I was looking at Sequence, which is seen as Sparkle, seen as stream.
Some streaming is even better, like for instance the immutable data that we talked about, where the address is always dependent on the content. So if the content is a glass, then the address has to be this, right? If you change anything in the glass, the address becomes completely different. So the advantage with these kind of data is it's self-verifiable. If the address is different, for instance, if you have an envelope, again in that example, if you put in a letter and write an address that comes to me, I'm not very sure whether that's the latest one that you gave me, whether that's an 8. So I need some kind of a consensus, right? Enough people to tell me that, yes, that's the latest version of the website that you're receiving, and then I trust it. But if it's an immutable data, I know that if I trust the data, the address has to be that because it's derived from the data. So there's what we call an opportunistic caching. So once you fetch an immutable data from the network, all the intermediary nodes, if they have enough capacity, are just going to cache it. So the next time you fetch that immutable data, it doesn't even go to the destination where it's stored. It's immediately got from the next one, right? Because it's self-verifiable data. And that, like corollary, helps in spam prevention somehow, because now if you are trying to do because get spam is the easiest spam to do on the network, right? It's some kind of a multiplication in spam. For a good spam, you need to kind of create a big data, put it yourself, so you're wasting your bandwidth and then wasting the bandwidth of the network. But for a get, you just make a small get request, and that file might be like a humongous file, and you're creating like a big spam out of a small work that you're doing. So immutable data kind of prevents it in a very funny fashion, because since it's cached, now if you do a spam get, the only person you're spamming is your immediate connection, which is kind of going to slow you down for anything else that you want to do in the network.
It's anti-fraud.
So it's kind of a very funny.
It's always anti-fragile networks.
Yes.
Yeah.
Kind of a funny way in which you kind of.
The concept of distributed denial of service ceases to exist on the main one.
Coming to the content to do with Cloudflare. Doing things like this.
It would just reroute as well, wouldn't it? You know, with DDoS or whoever mentioned DDoS, I mean, your traffic can be rerouted.
It costs you more bandwidth and resources to try and pull the requests down on the network to make the initial request than you're actually affecting the network. So you're doing more damage and cost yourself in trying to DDoS the network.
Yes.
Actually,
There's people selling clean pipe, they'll sell you clean pipes to DDoS for a fortune. So inadvertently, DDoS pays service providers. Very sinister.
In fact, like I think people might just run their walls on Cloudflare and stuff because they expertise in all these things, right?
Yeah.
And completely make a load balancing server somewhere else and then reroute and all that stuff. And then the reverse DDoS you, which would DDoS that kind of stuff.
Because they're using Quick, they're called a quiche.
Yes. How do you know? You seem to be following focus.
No, I was looking up to.
Oh yeah, okay, right.
Yeah.
They use so there are two competing libraries to be used. One is Quinn, which we are using. The other one was Quiche, that's run by Cloudflare.
Yeah.
The difference is like Quinn is much more modern Rust, and it's much easier to kind of consume.
Okay.
Whereas the Cloudflare one is like more. Before Rust had all these new bells and whistles.
Yeah, but they present it. I mean, this is where the presentation
Yes.
and getting the word out
Yes.
is got important. So how do you PR it?
Right.
Yeah, because Cloudflare got CDN and everyone knows them.
Yes. But we were planning on kind of switching over to Quiche or Quiche. I don't know how to pronounce that.
Yeah,
Quiche. Because like Quinn had some bugs initially, so we were almost flirting with the idea of jumping over.
Google
But then we
have done
didn't.
another one as well. They call it Quiches.
Right. But that's in some other language, right? Probably Go or something.
Niche.
Go. Yeah.
Yeah. Because Go is another one from Google.
Yeah,
Go is yours,
that's
right,
right.
yeah.
It's a Robert Pike or something.